Hello everyone, my name is Heather King and I'm a master's student at the University of Southern Mississippi under Eric Sayant, one of the PIs on this project. And today I'm going to be giving an update on the SALT consortium, which is the development of a breeding program for the Gulf of Mexico Eastern oyster using communal rearing of families and marker-based pedigree reconstruction. The SALT consortium was developed to assist industry and state agencies by developing a breeding program to improve production and market value traits as directed by industry needs, and also to develop a germplasm repository for the management and restoration programs. As you can see on this slide, there are people from the Business Advisory Council and the research team, including the states of Alabama, Florida, Louisiana, Mississippi, and Texas. The jobs involved in the SALT consortium consist of defining project objectives to address industry needs in the Gulf of Mexico, developing a breeding program to produce Eastern oyster with improved genetic values for characters of interest to the industry, developing a germplasm repository to include founders and select parents during successive generations of breeding, as well as testing improved diploid lines for triploid performance and cross with tetraploid stocks. A diverse founding population was collected along the Gulf states from East Texas to West Florida to allow us to evaluate the traits that were found most important to the industry, which included tolerance to high temperature and low salinity stress, resistance to Perkinsus marinus or dermo, conformation traits such as growth, along with survival, disease resistance in the hatchery, and reproductive traits. So on the slide, you can see that in the green are the tasks that we've already completed, yellow are the ones that are in progress, and then white are our future tasks. So we've already defined our breeding objectives, which are the traits to be improved, and that was based off surveys that we sent out to the industry in 2019 and 2020. We've collected our founder populations, which were those diverse sites that we had talked about in the previous slide across the Gulf of Mexico. And we've bred our F1 offspring, which happened in 2020. We've also measured the traits in our F1 offspring at the harvest sites that we've selected based off of those different environmental conditions. And our next steps will be to estimate the genetic parameters and design a selection index based off of those traits that we had found and what we have measured in the field. And following that, we'll estimate breeding values and select the best parents for the next generation that we do in 2022. And so further from that, we'll breed the 2022 generation, which is that F2 generation from our F1 generation. And then after that, we'll repeat what we previously did and estimate the breeding values of the F3 parents and the response to selection. So the method that we used for this was a common garden design, and with that, in 2020 when we did our spawn, we took those brooders from the different sites across the Gulf of Mexico. We performed our spawn based on the crossing design that we came up with, and then the offspring were mixed in equal numbers of fertilized embryos from each family. So through the larval phase up until the end of the growout phase, these were a randomized assemblage of all the families that we spawned during that 2020 spawning event. And during the Growout challenge, we measured traits, and then at the end of the Growout challenge, we harvested all of the oysters at each site that we deemed an appropriate environmental conditions, such as low salinity, a high salinity site, and then a variable salinity site. And then we genotyped these individuals so that we could then run a parentage analysis and determine which families these individuals came from that spawning event. So again, the founders came from different geographic populations incorporated in a mosaic-based population, and this consisted of those sites across the Gulf of Mexico. And the target for the spawning event was to use 100 males and 100 females total for the event, incorporating an equal amount from each different locality that we collected from. So spawning was planned to happen at the Auburn University Shellfish Lab as well as USM in the early spring months, but due to the COVID-19 pandemic, these were delayed and had to happen in late summer, which did affect the gamete quality of the broodstock oysters that were planned to use during the spawning event. So at the Auburn University Shellfish Lab spawn during August and early September, 204 crosses were produced, which was the planned amount of crosses in our crossing design. And there was an average of 275,950 embryos per cross, along with a 35.91% fertility. And the USM spawn that was planned the following week ended up getting canceled after the first day of spawning due to the poor condition of the broodstock seen in that spawn. So prior to the growout period, seed were monitored in nurseries at Louisiana, Alabama, Mississippi, and Florida, and once an appropriate size, we put them out in the field until April of 2021 when the growout period began. And so we had 7 total sites that we deemed for growout sites, but only 4 of them we harvested from based off of the environmental conditions at those sites. And those 4 sites that we harvested from consisted of Alligator Harbor in Florida, Mobile Bay in Alabama, Deer Island in Mississippi, and Grand Isle in Louisiana. And so harvesting took place from October to November of 2021. Something that we saw during this growout period was a high mortality during the early summer in Alligator Harbor, with some bags lost due to storm damage in Mobile Bay as well. And then another thing that we saw in Alligator Harbor was heavy spatting of the oysters. And this is something we might have to reassess in future growout plans in terms of how we manage the bags at certain sites, because each site does have a different way that is appropriate for best management. And so here you can see the different survivorship at each site along with the harvest size at each site. And another trait that we looked at was the back bend, because that is a non-favorable trait in half-shell oysters. So our high salinity site was Alligator Harbor, which I think a lot of you would probably know that. Mobile Bay was considered our low salinity site, and then Deer Island and Grand Isle were somewhat of a mid salinity site and variable. So throughout the growout period, we had a lot of ups and downs in the salinity at those sites. But with Mobile Bay and Alligator Harbor, we had pretty consistent high and low salinity patterns. In 2021, we did a second year of spawning using the brooders from the previous year to produce 160 new families and to produce a secondary F1 generation. And these 160 new families were used to do temperature challenges as well as salinity challenges. So the temperature challenges involved maintaining families close to the upper tolerance limit to simulate a summer heat wave, similar to what farmers in Alligator Harbor experienced, and I'm sure other sites in Florida may experience this as well. And then the salinity challenges consisted of simulating a rapid decrease of salinity following freshwater events. One thing that we were not able to look at in terms of our planned assessment of traits was the resistance to Perkinsus marinus. That could not be evaluated in this initial F1 generation, and this will be examined in the second generation, looking at different ways to do this. Future steps of the SALT consortium will consist of estimating heritability of thermal and low salinity tolerance and disease resistance. And these are things that we have been working on in these prior generations, and traits that are retained will be incorporated in the program in the F2 generation. Another thing is incorporating genomic information and estimates of breeding values. So there's a genotyping platform that's in development, seen for 2022 to 2023. And then also assessing the performance of diploid lines for triploid production, which will consist of a collaboration with 4Cs in 2023 to 2024. With that being said, I want to thank everyone for listening in, and I want to acknowledge the Gulf States Marine Fisheries Commission and NOAA as our funding source, along with Auburn, USM, and the UF teams for support during the culture phases and sperm processing, along with the people who helped us collect, such as BioWest and LSU. Thanks, guys.